63 is talking about two stones. So the first stone is thrown down at 2 meters per second and it hits the water below. The second stone is thrown a second later but hits it at the same time. And so the goal is to figure out the velocity of the second stone, what it must be thrown at, so we'll call that V0. And then I think at the end it asks us for how hard or how fast the two stones hit the water with. So let's look just at the first stone. And if you think about the first stone, its position equation I think makes the most sense because we have information about height and acceleration and initial velocity. So if we write out the standard equation, we want it to hit the water, thrown from a height of 50. Here's the key piece here. It's thrown down, so we have to use a -2 for the initial velocity. And then of course it's in free fall in terms of gravity. And the only variable left is t. So we'll call that t1. So if you solve that quadratic equation, you get something like 2.996. And for us, let's say it's just 3. Well, that means the second stone must have had a flight time of only 2 seconds. Because it said it's thrown 1 second later and it lands at the same time. So we now know that T2 is equal to 2. Well, if we know T2 equals to 2, we can write the same equation and figure out how fast it must have been thrown down in order to reach the height of the same cliff. So go to the ground, start from the same cliff, thrown down, so I'm going to put a minus V0, and you know the seconds are 2, and minus 1/2 gt squared, where t is equal to 2. And the only variable left in that equation is V0. So you can solve for V0. And when I solve for V0, since I put the negative sign in the equation, I'm going to get a positive 15.2. And I know that's really more or less the speed at which I threw it down. Down is built into the equation. If you left it as a positive, you would have got a negative for your answer. Both are just fine. The second part says how fast do they actually hit the ground with. And so we're just going to say we want an equation for the velocity. And so V1 is equal to -2 minus gravity's 9.8 meters per second effect for 3 seconds. And you get something like a -31.4. And for the other one, V2, it's thrown down at -15.2 minus gravity's effect for only 2 seconds. And so you get -34.8 meters per second.